roots of equations. Okay, the whole chapter is based on this question. Compute x such that f of x is 0. So this thing is called, the x is called the root of equation f of x when x satisfies f of x equals 0. Okay, note now, if I give you something like, let's say I give you something like this, gx equals 20. Okay, that is also considered a root finding problem. All you do is you write g of x minus 20 equals 0, or if this thing was f of x, that would be f of x equals 0. So everything can be reduced to a formula which is f of x equals 0, and that's root finding. Okay, you could also have, alternately, you could have g of x equals x squared plus 5x, I don't know, minus 2, something like this. You'll do the same trick. You will move it to the right, and then you have this thing, you'll write it as f of x. There you go. So g of x is some other complicated expression which I need to write down. Right? G of x could be, this could be something like e raised to x times sine x, I don't know, just something which is a function of x. Okay, so let's look at a simple motivating problem. Okay, we'll find the roots of a quadratic equation. So question is, compute x such that f of x 0, where f of x is this expression, x squared plus x minus 2. Okay, so a quadratic equation. Now what we know about a quadratic equation is that a quadratic equation can have either two roots, could have one root, or could have no roots. Those three cases are, if you draw f of x as a function of x, for a quadratic equation, you could have either this, in which case those are the two roots. You could have something like this. There'll be one root, actually two roots, but they are equal and opposite. So sorry, equal to each other. Or you could have no roots. One root, and then there'll be two roots. Okay, now, so clearly the best way to find the roots of a quadratic equation, for that matter, any equation, is to just plot it. Just make a plot of f of x. So if you draw f of x as a function of x, so the same one. Now this is drawn to say to a scale. I'm sure your calculator can do this. You'll see that this equation. Right. So let's just draw the curve. And as Paul noted, it would have will pass through 1 and it pass through minus 2. So those are the roots. Okay, so what we'll do here is we could graph it and get the values. Now it's really nice because I could just either use a calculator or manually draw different points, just put some values to x, draw a line, just draw a line between 2 points. Just if you have many points, it will actually look like a curve, and then figure out where the roots are. But if this was slightly skewed, if the quadratic equation was slightly moved and it passed through, I don't know, at minus 1.67, let's say, it would be very difficult to pinpoint that on the graph paper because you don't have that much resolution. So what we will do here in this course, in this part of the course, is that we'll find numerical ways of determining the root without having to draw any plots. Having plots does help, but you don't really need plots. You need an initial guess, though. So you need to know the sort of guess where the roots are. Now, if you don't know where the root is going to be, you can just keep guessing random things, and says the software will basically be able to come to conclusion where exactly the root is. What are we doing on time? It's 46. Okay. Let me just stop here. We'll pick up on Wednesday. But we'll basically have 3 methods of solving these roots. And I think for a homework question, I'll make you do this for multiple dimensions, not just 1 dimension. 1 dimension is easy. You can do it on a calculator, but higher dimension is hard. So 3 steps for root finding. Step number 1, we need to initialize. That is, we cannot just get the root unless we start with some initial guess as to where the root might be. Now, some methods that we're going to see require two initial values. While some require just 1 value. Okay, so we sometimes take this step for granted, but generating the initial guess is important because, as you'll see, if you start too far away from the solution, then sometimes you'll never really get the solution. It'll say that no roots, but actually there are roots. The second step is to have a search direction. Okay, this step is figuring out what is the next best guess to continue the iterative search. Right. So if I tell you, for example, the easiest way to think of this is if you are trying to, if you're in a desert and you're trying to find water, right? If you know that water is going to be found in the place where the desert has the lowest height, then all you're trying to do is to figure out where is this place which is the lowest height. So wherever you see a mountain up, you will not go up. You'll probably see how to go down, and so that determines which part of the desert you'll try to explore, right? So it's similar to that. There's a landscape, and you want to go to the point where the probability of you finding that 0 is the highest. So that is basically the search direction. So there are methods to do that, and we'll talk about them in just a bit. And the final one is you need to have a termination criterion. Okay, so when do you know you have found the solution? So this is when to stop. Okay, that's also important because, one is sometimes it's just too hard to get to the exact root. It's difficult to get exact 0. You might be accurate to 5 places, and it's very hard to get accurate to 6, 7, 8, 9 places. Now, that may be not true for 1 dimensions, but if it is 6 dimensions, maybe that's true. So what we do typically is we employ a termination criteria for convergence such that f of x is less than some epsilon, where this epsilon is user chosen, -6. So it's a very small value. And when you know that f of x is very close to 0, you can't literally get 0, but close to 0 would be -6 or -5 or -3, whatever you choose. You could say, I would stop now, and that is my value for x. For giving up, okay, as I said, sometimes there may be a case when there's no solution. So you need some criteria to say, okay, I give up now. And so typically what they'll do is you'll keep track of the number of iterations. By iterations, you mean every time you make a determination where to go, that's one step. Then you go to the next one, third one, 5, 20, 30, and maybe when you reach 1,000, you might say, okay, I've tried hard enough, I'm going to give up. So you keep track of iterations, and you say the iterations exceed the max iterations which you set. It's all up to you. You stop and just give up, right? Sometimes what happens is your initial guess is not good, and that's why you're not converging to solution. So maybe you'll start with a new guess and continue. Usual strategy that people follow is you run this the method till it terminates because of this max iteration, and you did not find solution. And whatever you got as the final value, you start the search again with that value. So that is what they call warm starting. Okay, you use one run to figure out what's the best value, but you need to have that in mind. You can't just keep running forever. Okay, so with those 3 things in mind, let's look at some of the methods. We're just looking at 3 methods to solve for roots. Okay, the first one is called bisection method.